Hi, welcome back to Mr. Chemistry, Electromagnetic Wave Formula Modified for Sound, Lesson Number 1. During Dolphin School, chemistry class professor Flipper and his lab assistant Beaker modified the electromagnetic wave formula and sent a sound wave through seawater at a rate of 1,531 meters per second and a wavelength of 15.31 meters. What was the sound's frequency? Alright, so in chemistry, when we talk about the electromagnetic formula, we use the formula C equals lambda V, where C is the speed of light, lambda is equal to wavelength, and V is equal to frequency. Alright, so now when we use sound waves instead of light waves, we use V equals F lambda, where V is the speed of sound, and now that speed of sound will be in meters per second, of course. F is still frequency, although in chemistry, F is denoted as V, okay? And lambda is still wavelength. Okay, so frequency is in 1 over S minus 1, which is also known as hertz, okay? Now, wavelength is also in meters. Now, we just denote that by M. So let's go ahead and let's clean this up a bit so we can have some space to work the problem. So I'm going to go ahead and get rid of the electromagnetic spectrum formula. And we're going to leave this other thing over here, the speed formula for sound. Now, you also have to remember that sound also moves at a faster speed through different mediums like air, water, seawater, metals, whatever material. And sound's speed of sound is dependent upon the density of the material. Remember, we learned that density is equal to mass over volume. Alright? So in this case, we're using seawater, and the density sound speed for sound going through seawater is 1,531 meters per second. Now, let's go ahead and work the problem. So what we know is we have V, F, and lambda. Speed of sound, which we know is 1,531 meters per second. The frequency is what we're looking for because we don't know what that is, and the wavelength is 15.31 meters. Now, all this right here, this looks kind of complicated, but it's really not complicated. All you have to do is take V equals F lambda, and we're looking for F, right? So we want to isolate by moving lambda underneath V. So the new formula that we're going to be using is F equals V over lambda. See how easy that was? Nothing to be really concerned about. All we have to do now is plug in our values and we'll get our frequency, right? So F equals 1,531 meters per second divided by our wavelength, which is our lambda, which is 15.31 meters. Meters will cancel out, and the frequency will be 100 over 1 over S minus 1. Or we can write that as 100 hertz. So this problem is actually pretty easy. And chemistry and physics are often intertwined with each other. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly. I will see you back here at Moosing Chemistry.